All right, well, welcome to the HASP 2024 Q&A and Technical Information video conference. This is the second one we've done. The first one in late September went over basically the CFP and the requirements, and then this one will be a little bit more specific on the template for the submission. Just a reminder that the submission is due October 30th before midnight Central Time. So you can just plan accordingly, emailing it to the hasp@lsu.edu account that's listed in the CFP is the preferable way to do it. You can mail it, but it's still got to get here before October 30th. So email would be the best. It could be in the Word document or a PDF, doesn't matter. So first off, I'll do a little introduction. My name is Doug Granger. I run the HASP program along with Dr. Guzik and Aaron Ryan, who are also here, and they are free to introduce. Well, HASP, we've flown 17 times now. We fly once a year out of Fort Sumner, New Mexico. Typically, the first week of September is when the launch happens. And so we start this cycle the end of this year. All the teams will make the assignment, we'll make the team selections at the beginning of December. Teams are free to start doing all the work whenever they're ready from assignment. And then it'll go throughout the spring semester. In July, we will go to New Mexico, Palestine, Texas to integrate HASP and all the payloads into the thermal vac chamber, which will test everybody on the extremes of the potential flight. So we'll go up to about 5 millibar and we'll heat the chamber up to about 50 C and get everyone a good, nice hot soak at altitude. And then we will cool the chamber. Well, we'll do the opposite. We'll cool first. But we'll cool the chamber to at least minus 50 C. So everyone gets a very, very cold bath as well. And that way we'll make sure that your payloads can work on the two extremes that you'll experience during the HASP flight. And after that, we will then move to New Mexico about 3 to 4 weeks later and try to launch right on the first week of September. So that's the general timeline. You can see more of it in the CFP. I don't want to go too much into the CFP. I'll leave that for questions if teams have specific questions. But I will switch and kind of let Dr. Guzik and Aaron introduce themselves if they so choose. Please feel free.
Yeah, so I'm Greg Guzik. I've been involved with HASP since the beginning of it. And, working with Doug and Aaron has been a real pleasure. And I would like to welcome all of our old returning people as well as our new folks into this continuing program. Aaron?
Yeah, hi, everybody. I'm Aaron, Aaron Ryan. So you'll be interacting with me throughout the HASP cycle. Good luck to everybody on their applications.
All right. So I'm going to just jump in and go over the application template real quick, and then I'm going to open it up to questions. I want the majority of time being questions that we could specifically answer from you guys, since we're getting close to application due date. The first page of the template is this little info sheet. Just fill it out as you see fit. Payload title, whatever you want to call your payload, the institution. This would be the primary institution. So we try to keep it to a single main institution, and you could have subs after, and you could have multiple institutions working. We just try to keep it to one. That makes the database a little cleaner. You can choose your payload class, either a small payload or a large payload. Submit date is the date you submit. The abstract is just a small 250-word section describing the goal of your payload. Team name, team website if you have one. This is the information for the student leads. This would be the information for the faculty advisor. I do not publish all your phone numbers. Do not worry. This is just for us and tracking purposes. We have a hazard checklist. CSBF and NASA has documented multiple hazards that we must track if they fly, and there are certain hazards that are just outright banned. If you look at this list, we've already X'd out the hazards that are banned completely. So there are no intentionally dropped components. There are no liquid chemicals, no cryogenics, no radioactive materials, no pyrotechnics. UV light. UV light is a little different. This is external UV lights. If it is completely contained inside your payload, that's a different entity. But no biological samples, rechargeable batteries are not allowed, and no high intensity light sources. That is, again, external. You do not want to blind anyone that is working on other payloads or working on HASP frames, stuff like that. If it's completely contained and blocked inside your payload, that is a different entity, but you still need to document it. We'll need you guys to sign it, acknowledge it. If you have any of these hazards, please mark it here. And there is a section of this application that has some hazard pages that you will need to complete. If you choose RF transmitters, you're going to have to go to the RF section and provide a good amount of additional documentation for NASA safety to approve this payload. There's your simple table of contents of everything that we need. We've broken it down into sections. Every one of these sections needs to be touched. You need to do not leave it blank. Do not leave my little section header descriptions in your section. We need you to fill out every one of these sections. Does it need to be fully complete? No. Like, do you really need to know your complete anticipated participation for integration and launch? No. We need to see that you've thought about it. This will change. It is subject. I know students come and go throughout the semester, so you're not going to know specifics, but we need to see that you've actually begun thinking your payload from start to finish. Weight budgets should be estimated. Your timeline should be a very decent estimation of how you're going to put your system together. Team structure, not exact, but we need to know how you're going to run your team. So that's it for most of these sections. So this beginning part, section 1, should have some fairly detailed information about your payload. You should at least have a very good working idea on what you're doing, how you are generally going to design and build your payload, what your objectives are, how your system should generally operate. Have a good idea of the major components of your system. Have a decent idea of the mechanical structure and how you're going to start. I will point out, for the mechanical structure, we say we want the mechanical design and layout. If you are giving me mechanical drawings require units and dimensions. If you give me just a box drawn on paper with no dimensions and no units, that is not a mechanical drawing, and that will not be rated highly. Same for your electrical design, thermal plan. It gets hot and it gets cold at the location of the atmosphere that we are. You can experience minus 50 degrees C very quickly. And as you rotate and face the sun, you can heat up rapidly. We go minus 50 to 50 in the thermal vac, but we have seen temperatures much higher than that. When the sun goes down, it gets really cold. So you need to have an idea on how you're going to manage both hot temperatures and cold temperatures. Team organization, this is all the details and layouts of your team. Payload specifics, a weight budget. You may not have all your measured weights, that makes sense, but you could at least have some estimates. Power budget, same thing. Your downlink serial, remember large payloads are 4800 baud. Small payloads are 12. So you need to have some idea on how you're going to downlink data. We do recommend that you downlink data. Most payloads that just write everything to an SD card and do not downlink any form of data, even if it's just housekeeping data, typically have issues. And if you fly with just a data card and have no housekeeping information on your payload, you have no clue if your payload works until you recover it days later. Having some form of data downlink, it does not have to be your complete data set, but something that tells you that your payload is operating as intended is very useful for all teams. And we highly recommend it. Uplinking commands. You do not have to uplink commands. Would recommend that you consider using the serial commanding and uplinking commands, or at least have the capability to uplink commands. We've had teams fix their payload on flight because they had the ability to uplink commands and change their system. So you can absolutely fly without a command. You run a risk of having some serious problems. You don't need to send commands, but I would recommend that you have the option to send commands and exercise that commanding stream if you need it. Analog downlink, we provide an analog downlink for most payloads. That does not come directly to the HASP system. That goes through the CSBF system, and that's a 0 to 5 volt line. But we do have that. If you choose and want to use it, we do have that capability for some payloads. Discrete commanding, same thing. All payloads get an on-off command. All the larges and three sets of the smalls get additional discrete commands. Using the discrete commands for important things, opening a shutter, maintaining that, running a pump or a switch or something that is vital to your payload. It's not a bad idea to at least consider using a discrete command or having the ability to send a discrete command to those. You could have both a serial and a discrete just to cover your bases to make sure you get your command. But those have uses if you need them. Payload orientation. If you need to be facing a certain way, or you need to be in the view of a camera, or you need a view of the ground, you need to specify where you want to be on the payload location. The website has a design of how HASP looks and where the cameras are, or where the cameras are normally located. If you do not give us your desired location, we will place you somewhere. And it may not be somewhere you want, or it may be out of the camera range or something else. But if you don't claim that you have a desired location, then we will move you to, we will assign to other groups their desired location before you get assigned any seats left over. Special requests. That is if anything outside of what's specified in this list above and in the CFP would be considered a special request. Height and weight requirements. If you have to go above the height limit, we need you need to fill out the special request. We need a height waiver request, and you need to document scientifically why this waiver should be granted to your payload and how it would impact your payload scientifically if we do not approve it. Just to get more data is not an acceptable scientific reason for violating the our guidelines. So you need a really good scientific justification for exceeding the specified guidelines of the system. Preliminary drawings, as I said, all preliminary design drawings require units and dimensions. If they don't have them, they are not design drawings. References, there's a reference section. Please include any references that you need and want to include on your system. In your appendix, basically, this is anything additional you want to include with your payload. Detailed drawings that we haven't added, detailed mechanical specs, electrical specs, anything can go in here. And then the appendix B is the hazard table. So if you're going to use an RF system, you've got to complete this form. If you know everything about what you intend to use, do it now. NASA safety will go through this. NASA safety is required to go through any of these hazards and approve them. As if we have all the answers quick enough, you can get approvals quick enough. The final version of the hazard table is not due until the preliminary PSIP in March. But if you already have this information included here, NASA safety can go through and approve it. You can get your early approval, and then you won't have to worry about this again. If you don't know, just include as much information as you can in these forms. Laser one is pretty big. The battery one, you can use off-the-shelf non-rechargeable batteries. You go buy an Energizer AA, that will be approved. That's not a problem. Any specialty batteries, you still need to include this. So if you go buy an Energizer AA off the shelf from the store, it's not a problem. Still document it so they have all that information and no one's going to hassle with you, but it'll be approved. Any specialty batteries, you need to include as much information as possible, particularly the UL certifications and the manufacturer's lists. I know this says just for lithium ion, but you want to do the whole thing for any battery. A link to the information data sheet would be fantastic. They can go, if it doesn't have the exact number with the data sheet, NASA safety can go explore and answer any questions that they have. We have allowed pressure vessels again this year, but this is a detailed amount of documentation to get a pressure vessel accepted. This is a lot of work. If you want to do a pressure vessel, you need to start answering all these questions as soon as possible. And that's pretty much the template. So I don't know if Aaron or Greg have anything else to add to this, but I'll let them speak up now.
Yeah, the available documents, the template and the CFP, and more importantly, the interface manual are available on the HASP participant info page, and all of the particulars of the serial interface, the power interface, the discretes, and all of that is defined within that interface manual, which is the second link I just posted.
Yeah, and I also should mention that if for some reason you decide that you need to request a waiver for any of the requirements like dimensions or telemetry or something else like that, you need to put in to your justification in the application what science or engineering would not be accomplished without that waiver. Just simply saying that you're getting more data or better data or whatever is not, but basically that waiver would be rejected. Further, you need to keep in mind that if in fact you need this waiver and your science is severely impacted if you don't, you need to keep in mind as to whether or not you are proposing the right experiment for HASP. So we're very serious about these constraints, and you need to be thinking clearly about it right now with your application.
The other thing, particularly about this waiver system, particularly for large payloads, is the height waiver. The height restriction that we have is 30 centimeters above the plate. When we put HASP in the thermal vac chamber, there is not much clearance above that. So large payloads, regardless, if you come back and say we need 40 centimeters and here's all the scientific justification, blah, 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 and it may be fantastic justification. If we can't put you in the thermovac chamber, it doesn't matter. So you need to be very careful and try to fit inside the constraints. There's a reason those constraints were set at where they were. So I've talked for like 20 minutes. I think I just want to open it up to questions. There's a Q&A section for teams. There's the general chat. You could raise your hand and or just ask. It doesn't matter. Please feel free. Go ahead and start asking questions if you have any.
Oh, actually, one additional thing. So we are unable to provide any sort of visa documentation or letter or anything like that for any potential foreign teams. Basically, the limit of the documentation that we can provide is your acceptance letter. So it will be on your team to sort out any sort of travel visas, unfortunately.
All right. Tavian, can we have any horizontally extended instruments on the payload? If so, is there any limit to this? So that would require a waiver and a bunch of drawings. If you're a large payload, it would depend on the direction. You'd need to be really specific about this. It's possible. You just, again, would need to provide a lot of information as to why you need that waiver. I'm not saying no, it's not. On the smalls, it's actually a little bit easier. So if you're applying for a small payload, we could do that. At least there's the possibility that that could happen. We do also, so if you've seen a picture of HASP, particularly the small payloads sit on their plate on their corner of the fiberglass, and we have actually dragged it out. So there's GPS units that can sit on that fiberglass bar outside of the payload footprint. We have put payloads, student payload components on those bars as well. You just need to document and explain exactly what you're doing in both your application and then the waiver request.
But also do not assume that your waiver will be accepted.
Yes. Does that make sense?
Yes, it does. Thank you.
Perfect. Anyone else? Please, guys, feel free to ask questions. Now's your chance to pick apart this application template. Wow. Maybe we're going to get some fantastic applications then. Is there any general questions you guys have? Veronica, go ahead. I'm sorry.
Yeah, I will jump in. I was giving time to students, but they may be still thinking about their questions. My students couldn't join today, so I'm gonna ask their first question they had, and that's the specifics on how different this payload needs to be and this application needs to be compared to last year, because they want to continue studying the same LunaSats we studied last year and just do a new study with them and all the sensors on board. But it looks like a similar study.
Nope.
So their concern is, what if this application looks similar to last year's, and that is ground for rejection.
We love and actually encourage teams to refly or fly with updated equipment or fly with better testing methods. I mean, this is an education tool as well. So an integrated increase of scientific study is always welcome. So no, it does not, they do not get a ding for having a similar payload to the previous year. We've got plenty of teams that build on top of. I mean, Dr. Patel has flown on HASP for 8 or 9, maybe even 10 seasons in a row. And he does iterations and he will make improvements, but his is a good long-term study to verify that his sensors work, and I mean, he's gotten those sensors patented too. So
Okay.
that is not a negative mark.
That
Yeah,
being said,
and-
the application should make clear, what is different, because the thing we don't want is just teams having some pre-built payload and they just fly the same thing, right? But if you're iterating, if you're improving, if you're addressing issues from previous flights, that's all valuable and persuasive information to include in your application.
Oh, perfect. Thank you so much.
All right.
I also, sorry.
What?
I also wanted to ask where we were able to get the recording.
I'll post it. I'll email it out. I'll post
Okay.
it to YouTube and then email it out to everybody. Teresa, go ahead. And then I'll go to IC.
So just for fun, how many cameras are there on HASP, and which payload spots are in view of those cameras? How's that for a question?
So there are variable. There are, this year we flew 3. So 2 payloads actually look, 2 cameras actually looking at payloads from different directions. And Aaron, there you go. Aaron's putting up the mount up there. So camera mount 1 and camera mount 2 are basically where our normal cameras are always. Camera mount 3 is a possible mount. Normally, we've also flew a camera that was downward looking. So like where payload 5 is, we had a camera there that was just looking straight down. Normally we fly 2 that look at payloads. We can fly a 3rd that looks at more payloads. I have a new camera in my possession that I want to try that may have a bit wider field, and we'll do some IR stuff. So when the sun goes down, we'll still get decent pictures. But typically this design is what you should be looking at for cameras. 1 and 2 are always on HASP. 3 is an optional, and then the downward looking is a downward looking.
So I have to say that downward looking camera is actually pretty cool. If you guys can fly that, it's fun to watch that one too.
It's pretty neat and actually has some decent information at times. But it's always contingent on if we have the space, because it does take a power unit away from a normal HASP payload. At least that's what we do when it's available. So yeah, I like the downward looking one, but it is the first one to get sacrificed when we have a need for power from somewhere else. Okay, I see. Are there any age restrictions for participants? Is it permissible for high school, middle school to join, or do they need to be exclusively, I'm assuming you mean collegiate students right there. If the participants are limited to students, does this include bachelor's, master's? Okay, so it's a big question. Yes, we have had high school teams participate. We've had a high school team from Belgium participate and did a fantastic job. We've had a couple high schoolers integrated into university teams, and that seems to work as well. Worked pretty well. I think it mainly works when you have a very strong leadership role. So either the faculty advisor or the team structure is built in a way that these guys, that the high schools, we haven't had a middle school, we had a high school. That they're structured and keep them going and keep them on target. I mean, high schools, like we've seen, I mean, everyone has multiple things to worry about and attention. And so sometimes it could be quite difficult for a high school team to be involved, but we have had that happen. Like I said, a strong leadership role helps there.
Right. That being said, the program is designed mainly for students at a senior undergraduate level. Above that is perfectly fine. Below that is fine, but we are going to be somewhat skeptical, and we want to, because we want the teams that we accept, we want to successfully complete a payload. So if we feel there is a lack of mentorship or that's not demonstrated in the application, we may not accept a high school team if it doesn't look like the students have the infrastructure there to support them to be successful. So,
and to go to the other end of your question, all of those are acceptable. We've done early faculty as well, but we have had a couple people get their PhD off of some of the science that they've done on a HASP payload. So yeah, either way works. It's just, yeah, going high school route, a good mentor, I think is the only way to get a payload like that built. But yes, as I say, that Belgian team we had, the Belgian high school team was one of the best teams we've had.
Is there any page where previous successful projects are published or referenced that we could take a look?
So on the HASP website itself, lostspace.lsu.edu, the HASP, if you go to the flight information section, there's this left-hand toolbar that has all the previous flights. And if you scroll through a bunch of those, most of them should be populated with previous monthly status reports, their science report, stuff like that. So I don't think they're all populated, and that's my fault. I need to go through and verify that everything is there, but there should be a lot of applications, science reports, stuff like that on that site.
Thank you.
Sure. Next question. If no hazards are being used, do we need to complete the appendices? No. If you don't have a hazard, you could just leave those blank or not include them. Okay.
You do have to fill out that form in the front though.
Yes. Just if you're not using a hazard, just say no, 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 and then you don't have to worry about the appendix hazard information. When will I receive email? About what? Ravish Shankar. I'm sorry if I just messed up your name. I apologize. If you're talking about the email about the video of this transcript, once it finishes processing and I get it uploaded, I will send the email out to the list that I sent announcing the meeting. So if you got the meeting request, then you'll get the email with the link to the video. Hopefully this afternoon. Else. The design we are proposing has exposed wires. Would there be a problem with this? What kind of recommendations would you give us for the protection of these? What do you mean by exposed wires? If it's just, cabling that's on the outside of your payload, teams do that. I mean, our EDAC cables, so the power that comes to you is in essence an exposed wire of some form. Are you just meaning bare copper wire, or do you just have cabling that will be on the outside of your payload?
So anything that's an exposed high voltage as defined by that, Doug, do you remember exactly what the cutoff is? It's like 30 or higher, isn't it? Or 50 or higher?
50 or
That's
higher is what they like. I don't
right.
think
That is definitely going to be unacceptable.
I mean, if it's enclosed and mounted just on the outside of your payload, yeah, you need a little more information there.
Right. But yeah, if you're talking if you're talking about some sort of exposed conductor, we would first of all question why. So the other sort of caveats to think about there is we are going to go through the cloud layer. So anything that is exposed has a chance to have moisture build up on it. So, and if it's something that could create a potential short, your power lines are all fused, and if you blow that fuse in flight, you are dead for the rest of the flight. So there's no way to recover from that, right? Because that's a physical fuse that has to be replaced, and we're not going to potentially endanger any other payloads. So it would really depend on the details. And my first question would be, why do you have exposed conductors? Yeah.
Ian, what common mistakes do you see in applications that make them less competitive? Oh boy. Dimension drawings that don't have dimensions or units. That is a very big one.
The biggest one, the biggest, easy red flag throughout the application is failing to comply with the template and failing to properly document the hazard or ignoring the hazard information. For example, even though one of the hazards is banned, you say, well, we're going to fly that anyway. That means that's banned for a reason.
Another one that I don't like to see is leaving sections completely blank. I don't need a 5-page book or a 5-page thesis on each section, but what I do need is to see that you've at least addressed that section. It could be one sentence. It could be, a table, and that's it. But leaving big sections blank is a red flag, and it typically means that someone wasn't paying attention before they submitted and didn't do a final review.
Also, I will add that you are not locked into the designs, like the particulars of the designs that you include in the application. We understand these are preliminary. You're at a preliminary stage, and potentially particulars of commands may change, particulars of like electrical schematics or anything. That is the reason there are further documents further on through the program where you will have additional detailed schematics and drawings and stuff like that submitted.
And things change, like when we have our monthly meetings, once that starts, we may say, okay, don't use this battery, look at this. Oh, you need to add a heater. Oh, because once you start getting a better idea of the actual components of your payload, you're going to find that maybe our preliminary design was just wrong or needs tweaking. So we are not holding your preliminary design as absolute or concrete. This is just a way to see that you guys have been thinking about how to build your payload.
Can I ask what impact do you hope to achieve with this program in the long run, apart from everyone gaining this experience?
Lots of experience, and actually translating all of, this experience translating into at least additional people coming in and participating in the aerospace industry in some form or another. I mean, we love hearing that, oh, this team had 5 people and 4 of them are now working at SpaceX or Blue Origin, or they've gotten, a position at NASA. That is wonderful for us. There is a brain drain on scientific minds, I would say globally right now. And trying to generate the next group of people who will help go to Mars, help study new materials to, translate on Earth. Hey, we've had teams that do Earth studies, figuring out burn patterns on ground cover and stuff like that. We've got a lot of scientific questions to answer, and if we could at least stimulate some minds to continue their progress, that is fantastic.
Thank you.
Teresa.
You're on mute.
I just want to give an example. I started tracking when I started doing these projects, I started tracking internships, scholarships that students reported back to me that they had gotten because they had participated with HASP and they had real skills. And, I have several students now at places like Millennium Space, Blue Origin, Tesla, and they have told me, and I'm a community college, and they have told me that was not their training at university. It was what they were able to show that they did while participating on HASP during their interview with Millennium Space, for example, that got them the electrical systems engineering lead position. Really important. What I make my students do is really important to have them keep a digital portfolio of everything they do, this including the circuits that fail and the circuits that work, or the mechanical design that failed and then how they fixed it. Because then when they do their interview for their internship or that job, they can bring up that digital portfolio, and that's huge. That is more important than a 4.0 at whatever university they end up at. At least that's been my experience with my community college students. They're in a lot of great places because of this project.
Yeah, our documentation can sometimes be hard. We've tried to curtail it a little bit, but our documentation requirements can sometimes be difficult, but there's a reason for that. That's what teams are going to run into in the real world. And this is very much a simulate a design to completion of a normal payload that you would experience, maybe not as detailed. You don't have as many PDRs and CDRs as, say, a full NASA flight, but it's conception to completion and documenting that whole process. Any more questions? Please feel free, guys, we have time. Is there any more questions about where to find documents or data or anything like that? The HASP website should have everything you guys need. If not, you're feel free to email us. You can email hasp@lsu.edu, and that goes to all three of us, and so we can answer questions there as well. But I'd like to make sure that you guys are all good to go for your application. If I see, go right ahead.
Do you have any scientific or engineering problems or challenges that you would love to see some of these payloads addressing?
I think of engineering challenges. Offhand, I can't point to a specific one, but I will answer it in a different way. I have gone through in the past and tried to match all of the HASP payloads to its NASA Mission Directorate corollary. So NASA has a bunch of different mission directorates. Helio, sun research, there's planetary research, there's astrophysics research, there's earth science research as well. and there's human research. And we've actually had components that meet every single one of those. Out of all the payloads we've flown across the past 17 years, we have touched every single one of those mission directorates. So there's plenty of science to go around. Could I tell you what you guys should specifically study? I don't think I probably should or I can, but it's open.
Yeah, I would agree with Doug. I mean, we don't really specify a project for the students because we want the students to do that research. We want them to come up and do their literature searches and look at things that are important and come up with the reasons and the science background as to why they're doing what they're doing. So so we don't specify anything, and that's been very successful for the last 16 flights, and we have a very wide range of projects going on.
So sometimes they give like a broad topics, but I understand the point and the reasoning, and yeah, it's nice to see what the teams will come up with and maybe some nice surprises.
Yeah, I mean, there are a couple, so our hazards do limit some, meaning the biological samples, we don't do biological samples because that requires such a paperwork intensive study from NASA that it just becomes difficult for a student payload to deal with on a yearly basis. You know, if you had a real large experiment, massive money type experiment that is a multi-year project, it's different when dealing with NASA safety and all the clearances you need to get. But a yearly payload, the time frames can be quite short for getting clearances and approvals and stuff like that. So that's one of the reasons why we've had to limit access to certain scientific studies. It's difficult to get the paperwork done. And this year might be even more fun considering, you know, NASA safety may not be around for part of November and December if our government can't decide to actually pull their heads out and come up with a budget. So yeah, they may be off work.
How about come up with a speaker first, Doug?
Yeah.
Right. But anyway, something important to keep in mind when you are trying to decide a topic, think about the flight parameters, why you are proposing to fly on HASP as opposed to, say, like a sounding balloon versus a rocket payload versus something that can just be accomplished in like a thermal vac chamber, right? So, you know, we're providing a relatively long, several hours, greater than 10 hours at 120,000 feet altitude, right? So if, you know, you want something that's relevant at that max altitude, probably not something that is changing with altitude just because we go up and we stay there. We don't go up and down a bunch. You know, or, you know, we've previously had some teams, they were like proposing some sort of fire extinguishing system. And, you know, we rejected that because one, it was a hazard violation. It would also negatively impact the other payloads. And also the big question was, well, why can't you just test this system inside a vacuum chamber, right? So keep in mind the particulars of the actual platform and the flight profile. You know, that's.
We've had teams like, I mean, this year we had teams testing some prototype lunar sat payloads. One team is doing a very big ozone study and collecting ozone on the way up, and then it flowed, and then on the way down. We had another team doing a communication study for the eclipse that's coming to the US, both tomorrow, the annular, and then a big one in April. So when we have teams doing all kinds of, particle studies. So there's a lot of options. We even had a team a couple of years ago testing a material used to make an inflatable dome if you were ever going to Mars or the moon or something like that. Testing the material, if it was capable of inflating and forming and then compacting back down and then re-inflating and forming. Yeah, we've had some pretty interesting teams. A couple teams trying to do star trackers, a couple teams trying to do solar, sun trackers. So there's a lot that's capable, and we've had teams that actually have downward facing cameras that were actually studying vegetation. One guy studying sound mechanics through the upper atmosphere, listening for dynamite detonations in mines and stuff like that. So yeah, it's a broad topic. That's why we typically don't suggest anything. It's open to everything almost. Any more questions? I think we've got everything in the chat. Yeah. All right. Well, we're approaching the 11 o'clock hour. I mean, I am free to stay if you guys want to keep asking questions. If not, we could end a little bit early, and hopefully that means everyone's getting to work on the application.
Thank you.
All right.
Thank you so much.
Absolutely.
Bye
Any
bye.
more questions there, guys? I see. Do you have one or you're good?
Okay.
Is there a page limit on the proposal? No, there is not an upper or lower page limit, but remember, we are reading a lot of them, so be concise. But yes, we are not limiting you to 5 pages or anything like that. Provide the amount of detail that you want to provide, but try to be concise and on point with what the data you're including in your application.
But also, if your design is far enough along where you have detailed mechanical drawings and schematics
Put 'em in.
or software flowcharts, feel free to include that as like an appendix if it does not seem relevant to a particular section, or if it's like 20 pages of drawings or stuff like that. So
All right. Well,
What is the typical duration of the flight?
so our duration of the flight, we request a minimum of 10 hours at float and a requested or desired 20 hours at float. Typically, I think our average is somewhere around 15 hours at float. So that means that a typical flight day would be, we're there at 3, but launch to float takes about 2 hours. Then you would float for an average of 15, and then it takes about 90 minutes to come back down to the ground. And then the recovery crew gets there typically the next day and tries to pack things up. And so HASP does not return back to the launch facility for 2 to 3 days. So 15 hours at float is a decent average of all our payloads.
And you're returning back the data to the teams.
Correct. So we have, if you are telemetry using the data downlink, you're getting data the way our system currently works is data comes down continuously to our ground station. Our ground station then pushes data to our website, and teams would get data every 10 minutes throughout the flight. And then if you also store data locally on your payload itself, once we get the whole system back, if you're at flight, once we get the whole system back, we give you your payload right to you. If you're remote and we want to, then we just need to email, send the payload back to you. So yeah,
Thank you.
it depends on your location. If you actually come out to the flight, once HASP returns, we unscrew you from the frame and just give it to you. Otherwise, we'll put it back in your box and ship it back to you.
If
But
there
it
is,
is designed so that teams can operate remotely. So commanding that that your team would be requesting is completely over web interface. Your data downlink is available also through a web interface live during the flight. And there's typically those cameras that were discussed earlier. Those will be live streaming during the flight.
if anything comes up between now and the deadline, I believe we can send an email to ask.
You broke up, but I think you were asking if you have any more questions, can you send an email?
Yeah.
Yes. And I'll put it in chat. That email address comes to us all the time. So if you have questions, feel free to send a note to send a question to that email address. hasp@lsu.edu. All right. Any more questions? All right. Well, if I don't see it, I don't see any coming. So I hope everyone has a very good weekend and good luck on your HASP applications. Bye, everybody.
Thanks. Bye.